So one of the things that Python has available to it is this thing known as modules. Basically, this is one of the attractive things about Python, is the fact that so much of it has already been sort of pre-built for us. And one of the things you can think about is, why reinvent the wheel since these things are already available to us. And so you can see we have a whole slew of these built-in functions at our disposal. We've already started to mess around with these, the string, the int, the float, the print, and the input options. But let's say, for example, this guy, that first one. Why not tackle the first one? Well, ABS. If we kind of came in here and we took a look at what ABS stood for, you see that it's going to give me the absolute value of an argument. So something like -4, in this case, will give me a +4. And why is this important? You might remember we talked about something known as epsilon, a very small number that we used in approximation. So, okay, now we have epsilon, and you might remember some of the things that I can do. Maybe I do x equals 1 minus 0.1 minus 0.1 minus 0.1. Now, I should get 0.5. That's logically kind of what I should be seeing, but I get that 0.7 is what I should logically be getting. But as you can see, I'm getting sort of this trailing effect of zeros until I get a rounding off error. And this is where approximation came into play. What I would be able to do is I could say, oh, well, if I do x minus what I was expecting, 0.7, as long as that is less than my epsilon, then I get a true statement. But we run into a slight problem, if you will. Because what happens if instead of 0.7, or x minus 0.7, I said something like 0.2? 0.2 is not really approximately 0.7. However, based on the logic that I've applied, that still follows the true kind of mentality. So how do I fix this? That's where ABS comes into play. You see, the reason why this works is because if we do take a look at that, 0.2 minus 0.7, 7. All right. As we can see, that is still kind of less than epsilon. So the problem is we have to fix this. In that case, again, ABS comes into play. I can come in and I can say ABS. As long as it's now the absolute value of this math equation is less than epsilon. In this case, I'll get a false. But if I come in and change this, my x, which is the rounding out error, I should get a true.